All right, guys, so we're going to do these two examples. So the first example is graph y is equal to negative 4x plus 2. So I wrote a little graph out for you. And so the first thing we're going to kind of do is do the x-intercepts and the y-intercept. And so for the x-intercept, you essentially, set the y equal to 0, multiply both sides by x plus 2, you get 0 is equal to negative 4, so there is no x-intercept, so not applicable. Vertical asymptote. So now you want to essentially figure out what the vertical asymptote is, and the way you do that is essentially looking and seeing what's going to make the denominator 0, right? What can't this be? So this can't be negative 2, right? So negative 2 plus 2 is 0. That doesn't work out, so negative 2 is my vertical asymptote. So x is equal to negative 2. Now my horizontal asymptote essentially is going to be 0 right here, right? Your horizontal asymptote is going to be 0. That's just from all those formulas that we've done. So y is equal to 0. And then domain, it obviously is going to go from negative infinity going to negative 2. And then, positive or negative 2 to positive infinity. So now we have to go down and actually graph it. So what you want to do essentially is graph your vertical asymptote and your horizontal asymptote right away. So my horizontal asymptote is just the axes. Kind of hard to essentially do that one. And then your vertical asymptote is at negative 2. So negative 2 is right here. Okay. So the way that I like to do these essentially is pick 3 values to the left and 3 values to the right of every single vertical asymptote. So this vertical asymptote I could do, negative 3, negative 4, negative 5. And on this side I could do negative 1, 0, 1. Negative 1, 0, and 1. Okay. So then we actually just type that into your calculator, so you can substitute, negative 5, plus 2, and then negative 4 divided by that. And you should get roughly 1 1/3. Just say 1.3. Okay. Then you substitute negative 4. So negative 4 plus 2 is negative 2. And then negative 2, negative 4 divided by negative 2. Okay, I'm sorry, negative 4. Right? So you end up with 2. And then you substitute negative 3. So negative 4 divided by negative 3 plus 2. Okay. You should end up with 4. Okay. Keep going. So we've got negative 1. So now we substitute negative 1. So negative 1 plus 2 is negative 1. And then negative 4 divided by negative 1 is just going to be negative 4. Okay. Then you can substitute 0. So 0 plus 2, negative 4 divided by 2. Then substitute 1 in. And you do negative 4 divided by 1 plus 2, which is again negative 1 1/3. So now we essentially graph this. So negative 5. So negative 2, negative 3, negative 4, negative 5. Negative 5, it's at 1.3. At negative 4, it's at 2. At negative 3, it's at 4. So we see that the graph is going to go like that. And then this side, negative 1, it's at negative 4. So 1, 2, 3, 4. At 0, it's negative 2. At 1, it's negative 1.3. So again, we can see the graph is going like that. When you're drawing this, just make sure it does not extend across any of these asymptotes. So that's number 1. 2 is a little bit more complicated. All right. So number 2. First thing we want to kind of do is do the x-intercept. So we set this equal to 0, set the y equal to 0, multiply by x squared minus 9, we get 0. Then we divide by 2. So we'll have 0 is equal to x squared. Square root of 0 is just 0. So my x-intercept is at 0, 0. Then my vertical asymptote. Again, you look and see what the denominator cannot be. So you could just set the denominator equal to 0. So x squared minus 9 is equal to 0. So x squared is equal to 9. Square root of 9 is 3, or negative 3. So you have a vertical asymptote at 3. And you have a vertical asymptote at negative 3. Okay, horizontal asymptote. If the degrees are the same, you're just going to do the leading coefficient of the top divided by leading coefficient of the bottom. So 2 divided by 1 is 2. So y is equal to 2. And then your domain is going to go from negative infinity to negative 3. Then from negative 3 to positive 3. And then from positive 3 to positive infinity. Okay. Now, we actually start drawing it. So first vertical asymptote's at 3. Second one's at negative 3. And then the horizontal is at 2. All right. So now you've got your t-chart. And so what you could do is, again, 3 in between each vertical asymptote. So I could do 3 on this side. So if I'm at negative 3, I could do negative 4, negative 5, negative 6. Okay. And then here, I already have 0, 0. Right? I've got this point right here. I can just do 1 on either side. So I could do 1 and negative 1. And then last, I can go on this side. So that's if it's, 1, 2, 3. This would be 4, 5, 6. So 4, 5, and 6. All right. Going from there, you just substitute those values in to see what you get. So if you substitute negative 6 in, you end up with, let's see, where did it go? 1 second. All right, if you substitute negative 6 in, you get 2.6 repeating. All right, so 2.6. If you substitute negative 5, you're going to get 3.125. And then if you substitute negative 4, you're going to get 4.57. If you substitute negative 1 in, you get negative 1/4. So negative 0.25. Since this is quadratic, it's actually going to be symmetric, so you can just make this negative 0.25 as well. And then 4, 5, and 6 are going to be the exact same values. Okay, so at 4, it's going to be 4.57. At 5, it's going to be 3.125. And at 6, it'll be 2.6 repeating. Okay, so then you actually graph that. So we have negative 4, 5, 6, and it's 2.6. So 2.6 is right about here. Negative 5, 3.1, and then negative 4, 4.57. There you go. It'll be the same on the other side. I'm just going to sketch it. Okay. So same thing on either side. And then this one is negative 1/4. If you wanted to do negative 2 and positive 2, it just would show you that the parabola is like this. And there you go. So that's kind of a little refresher on how to graph these guys. If you've got any questions, let me know. I think we have another live Zoom session at some point. But essentially your homework tonight is just going to be a couple practice problems. There's 4 problems, and so they're all kind of very similar to this. And I also gave you some documents on 8.2 and 8.3 under pages that you could look at kind of for some of the formulas and for some extra problems if you wanted it. If you're unsure if you graphed it right or wrong, once you're done graphing, just go to Desmos.com and type in the graph, type in the equation, and you should get the same thing that you got in your paper. If not, you can kind of dissect and see where you went wrong. All right, guys, so that's example 1, example 2. Have a good day.